different devices, either set-top box or others, whatever uses web management interface. And the thing is, by using that file system traversal, you can get on the device and get different files and for different cases. In a lot of cases, we actually are able to find like unencrypted password or simply certificate for authentication, things like that. Just because people didn't really protect the data on those devices. And of course, you can always try other standard web application assessment against those web management interface, and you will have different findings. There are also weak and default account and passwords. It could apply for web management interface. It could apply for telnet, secure shell, or just simply SNMP. Okay, so a lot of service providers, they still use just plain public and private to manage all devices. The next section we'll talk about is delivery and management network. So for the delivery and management network, usually there are hundreds of servers on that network. It includes both IPTV and potentially non-IPTV, the old telecom servers. And the access to other servers is the major point of attack. You can see middleware servers, you can see streaming encoding server problems, and potentially you can also access to other servers. So to access to other servers is pretty easy. All you need to do is just change your IP address to the network, to set-top box's IP address range, then you are on. Okay, different service provider will use different IP addresses network, and you just need to sniff the network and figure out what's the IP address range they're using, and then you can get on. And then the next thing usually you will do is scan the network range, and you can find middleware server, database server, and different other servers. What can you usually find? Basically, for example, we have found passwords in spreadsheet or password in configuration files where you can get through directory browsing. Okay, so a lot of people, they don't protect the internal servers because they consider this is a closed network. It's owned by the telecom itself, so they may not put as much security controls as internet-facing server. We have found web management interface for middleware server or database servers, and the web management interface for like Oracle database connections where it's controlled with the customer data and all that. And also we even found like movies for text, right? So you can find some people, they will leave DVD files on some servers for IPTV testing, and they are not protected, and you can find that. So you can find a lot of things on the management servers, and it really depends on how careful or how security aware the telecom is. Okay, so the next thing we want to talk about is the streaming and encoding server. We'll talk about two things. One is the RTSP buffer overflow, and then the next thing is we'll talk about the weak TCP/IP stack. So the first thing in real-time streaming protocol, it's actually a request. It's actually Internet RFC standard. You can check out www.rtsp.org to see the detail. Most of the time, you will see it being used when someone wants to purchase video on demand. For example, the first content, there are 4 different methods being used: describe, set up, play, and get parameter. RTSP basically is a protocol similar to HTTP. It's an ASCII-based protocol where everything is human-readable format. There's nothing like an XML tag or binary protocol, nothing like that. So one of the problems you could find is look at this describe request. Basically, you have the describe, and then you have the RTSP colon / VOD server, whatever that IP address is. Usually, RTSP service is running on port 554, and usually you can access to a certain provider's asset. The asset here basically is a video for being purchased by video on demand. And this is kind of the simple request you're doing. And you can either change the URI for the describe methods to get a large chunk of data, and then you pretty much get a buffer overflow on the video on demand server. Okay, So other location of the implementation might have the same problem where you can change the method or change the URI or change other places, and you can still reach your buffer overflow result. The result for buffer overflow is pretty much either a denial of service attack or you get control of the VOD server. And once you get control on the VOD server, you pretty much have your own IPTV service, and you can just purchase whatever video you want, potentially free, I guess. Yeah. So in order to test that, there is something called Protos, and potentially you can come up with a set of programs to do Protos for RTSP protocol. Just look at the ABNF protocol form of the RTSP protocol, and then generate different test cases, and using the Protos tools to do that. Another thing is a weak TCP/IP stack. So what we found on the set-top box actually also exists on the streaming and encoding servers. It's kind of a well-known thing that for some reason no one really fixed that. So some of the streaming or encoding servers, they are good at sending data because they are designed to do that. They are handling millions of customers at the same time. That's how they are designed to do. However, they are not good at handling incoming traffic. Okay, so potentially a MMAP 4-port scan could degrade the server response from 10 milliseconds to 3,000 milliseconds, for example. Okay, so that's kind of something happens in the real implementation, and if you make the scan more aggressively, or do other scan, sometimes it could cause a denial of service situation where you could have killed the encoding or the streaming server. Most of the time, the encoding or the streaming server are only responsible for the normal TV programming multicast. They are different than the video on-demand servers. Okay, but they pretty much most of the streaming and encoding servers would have the weak TCP/IP stack problem. Okay, so the last component we'll talk about for security problems is finding the backup and finding the source and VOD manager thing. So what happens if content source? The goal for people to attack that is pretty much you want to steal the source directly, bypassing home network, bypassing delivery and management network, and that's one of the goals you do, right? So remember last year, it was the laptop stealing year. You hear about the news like, people stealing laptop or people stealing backup tabs. Almost every bank or a lot of major companies, they suffered some loss last year by being stolen, by the backup tapes or laptops being stolen. So those could be a way for people to do that, to attack the telecom. And the other way is finding the source. For example, tomorrow there will be a talk about how do you hijack a satellite connection. It's not totally about IPTV, but it's definitely, since satellite is one of the sources that IPTV could rely on the content source, so it's definitely an interesting talk that you should check it out. And video on demand manager. In some of the cases, you will be able to find a web management interface or potentially more on the network a set-top box could reach, which could manage the video on demand files from the content source. Okay, so earlier we were talking about creating buffer overflow problems on the video on demand servers, and now if we are able to go to the source, go to where the video on demand is being managed, then it will make it easier. So those are the problems on the content source. We'll kind of like, after we talk about the security problems, technically, we will talk about how those security problems could related to privacy, confidentiality, integrity, availability, or interoperability as a summary. So the privacy part, basically people care about how telecom handle the customer information. A few months ago, probably people heard about that, like AT&T talk. AT&T has a policy pretty much like they own the customer information. So that's become a debate in the US. So privacy is an important thing that people will care. So far the good thing is when you are using IPTV, you are not transferring anything more than just like, for example, the PIN number you set up or the account number you have with a telecom. Okay, pretty much nothing more would be sending out from your set-top box. But there could be potentially vulnerability on the back-end billing system if you spend enough time to dig into the network. And in that case, what people can find will be more like the whole database of the telecom and with everyone's account and names and billing information. Okay, so in that case, there will be a big privacy breach. And also, there could be argument regarding to how telecom manage the CPEs, the customer premise equipment. Do they own that, or does the customer own that? The access usage acceptable usage policy. How do they set up, and how does the user want to do that? So those could be the concern when IPTV vendors are trying to provide a service or push the service. People might have concern adopting that. And of course, there could be legal involvement when the telecoms are trying to sell the services in either the US or other regions. Confidentiality for video content. So not all of the telecom will implement digital rights management. It really depends on how much they want to do or how they want to, how they treat the content, whether they want to protect to the extreme or they are okay just leave it open when they just need to take care of the part from the video server to the home network. Okay, and remember there is always the analog hole problems right now, where from your set-top box to the TV, right now most of the signals are still unencrypted. Before, so you can still steal the content through that, and the people are trying to develop HDMI standard to address these issues. So in the future, if you buy a TV, it might support HDMI, and the HDMI will actually try to encrypt the content between the set-top box to the TV. So if you want to try to steal that content, it will just be harder. But as we mentioned earlier, when you get onto the IPTV, you own the set-top box. You can pretty much do a lot of different things to the set-top boxes. And for Windows Media Windows rights management, people are writing programs to strip the DRM out of the content. So things like that could happen in the future when the IPTV service is more widespread and people feel the need to rip off the content. Okay, and also we mentioned about all the backup tapes, laptops losses in 2005. There are really a lot of people stealing information through that way. And for newer set-top boxes, they can also act as a digital video recording. And so, how the data is being protected and how the data can be how do we expire movie content on the set-top box in 24 hours? Right, so those are the problems. The key has to store somewhere, either on the server side where the client has to access to that every time they want to watch it, or it's stored locally on the set-top box. So it really depends on how people implement that. Authentication and authorization. As we mentioned earlier, it could be as easy or as simple as sending out a MAC address, but it could be as complicated as a combination with AO2.1x and or DRM public key, private key authentication. So it really is depending on vendor to vendor. And other interactive applications, as we mentioned, in the future, more and more people will introduce interactive application, either online gaming, either more interactive online ATM or things like that. So those things will have their own individual security problem, and you will probably see the set-top box growing to be a home entertainment hub or entertainment center, and then it pretty much will probably grow back to like a normal computer. Integrity. Basically, we're looking at how can you modify the content while for the telecom. For example, multicast and unicast securities. There are some security issues regarding to multicast and unicast itself, either on the device side or the protocol side. And so far, I don't think it's a very, very serious problem yet. And in the future, if the service is more widespread, it might become a more important issue. And also content source security. So when people get onto the video on-demand manager, can people change the content before they replay that, or can they modify the content on the fly? So those are the things people will care about.